This is a video on how we begin to draw our organic compounds. So we're going to look at all the carbons, hydrogens, all these atoms, how we start to draw them out, and some simplifying ways that us lazy organic chemists use to draw them faster than drawing out all of the atoms. Let's jump right in. So let's begin with this molecule called octane. It's octane. We'll learn how to name these later, but the oct prefix means 8, and you'll see that there are 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms in this molecule. And the ane ending is because all of these carbons have single bonds between them. But we really don't care about the name right now. I want to look at how do we draw this compound. Now I drew it. I didn't force you to sit there and watch me draw it because it takes quite a bit of time to draw all of these lines and all of these atoms to show every hydrogen and every carbon atom. But this shows every atom and how they're bonded. There is an easier way of drawing this and a faster way to draw it. And we call that other way of drawing it the condensed structural formula. So this compound, instead of drawing out every hydrogen this way, I can simplify it by drawing something like this. This is a carbon with 3 hydrogens on it. So I could draw CH3 this way, and that's bonded to a carbon with 2 hydrogens on it, bonded to a carbon with 2 hydrogens, and we can just keep track and go down our chain here. And this is a CH3 again. So this and this are equivalent. They mean the same thing to us in organic chemistry. So this is much faster to write if I just write CH3, CH2 than drawing all of these out. I can even simplify this even more. I can leave out these lines if I wanted to. If I drew CH3, CH2, 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 CH2. These are equivalent as well. So you can draw out the bonds, you can leave them out if you want. I can even draw this a little faster. I see that all of these are equivalent. There's 1, 2, 3, 4, 5, 6 CH2s in the middle of this. So I could write this is a CH3 with 1, 2, 3, 4, 5 CH2s. So this means we repeat this 5 times. And then I have this CH3 on the end again. So all 4 of these written this way, no matter how I write it, those are equivalent. So I like this one if I want to see all of the atoms and how they might react. I like these if I want to just draw them out faster and still see most of the atoms. This is if I'm typing it out on my computer, or it's a little harder to see what the structure of this looks like. I like seeing the long chain if I can. But you can start to simplify this way if you have a whole bunch of atoms and you need to just show quickly what you're talking about. Now, these are called the condensed structural formulas. There's another way of drawing this out that's also pretty quick. We call that the line angle formula. So these are condensed structural formulas. So I'm just condensing it down and drawing them out. The other way is called the line angle formula. And this is what makes organic chemistry look really cool when it's written down. It's a way for us to write this out in a shorthand notation using lines and angles to represent where all of these carbons are. And the way that works is whenever I have a line, at the end of a line, that represents a carbon atom. Or where 2 lines come together, that also represents a carbon atom. So this would be a carbon, this would be a carbon. So if I want 1, 2, 3, 4, 5, 6, 7, 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. This is the same as this. 1, 2, 3, 4, 5, 6, 7, 8 carbons. There's 8 carbons. So if somebody drew it this way, and they said, okay, here's my compound. If I wanted to know what does that really look like and draw it out in a longer form, I could take this and put a carbon at each of these ends of a line or an angle. So that follows along with my line angle formula. And then if I know where this is where the carbon atoms are, knowing normal bonding patterns for carbon is a carbon atom likes 4 bonds to it. This carbon, if I don't draw any other atoms on it, we imply there's hydrogens for all those other atoms. So if this carbon only has 1 bond that's drawn, that means it has 3 hydrogen atoms on it to get to 4. This carbon has 2 bonds that are drawn between other carbons. So if I have to get to 4 atoms, that means it has 2 hydrogens on it. 2 bonds, I need 2 more hydrogens. So you can see how that starts to tell me what it looks like. Because all of these hydrogens are implied, I'm just going to write H3 here. All of these hydrogen atoms are implied from this line angle formula. That's a simple explanation of how to draw condensed structural formulas or line angle formulas. You will get better the more you practice. If you watch the next video, I'll give you some examples of more complicated molecules and how we can draw these formulas for those.